Digital Twins online seminar series. Yeah, so Willem Jan is our speaker today. He asked a few minutes ago whether there was any introductory overview of this community and this seminar series. There is a bit on this slide here on what it's about, but what is missing on here, I realize, is that at least in terms of background of organizing and steering committee and speakers we've had so far, it's been very much focused on high-tech systems, cyber-physical systems, tech. And that is not on purpose, but that's what our background is. But in light of that, it's a real pleasure to have Willem Jan Knibbe of Wageningen University and Research as a speaker today. Willem Jan has a background in meteorology and astronomy, I found out. He's worked in Dutch traffic research, the National Statistics Bureau of the Netherlands, and in water quality research. But in recent years, he has moved over to Wageningen University and research. And Wageningen is really the University of Agricultural and Life Sciences in the Netherlands. And there he's the director of the Wageningen Data Competence Center, which bundles or focuses the research and teaching around data science, AI, and applications of those techniques, including digital twins, across Wageningen University. And today, Willem Jan is going to talk to us about digital twins in the life sciences. Before I give the floor to him, let me quickly show you the schedule for the upcoming weeks as well. So 2 weeks from today, we'll have Eugen Schindler of Canon Production Printing giving a talk, which is on high-tech systems again. And then on November 29th, we'll have a panel discussion about a research agenda for digital twins. And I think by now, all but one of our speakers in this first series have been confirmed as panelists. So that is definitely something that we're looking forward to as well. So Willem Jan, it's a pleasure to have you here today, and I'll stop sharing and you can start sharing, and then the floor is yours.
If all works well, then now you should be seeing my first slide. Is that correct?
Yes.
Okay. Thank you for your kind introduction. It's a pleasure to be here, and it very nicely fits the challenge that we have taken up to present this work to you, as Luc sketched, from a quite different community as that we are currently working on in Wageningen. The Digital Twins is a so-called investment team of our university, which means that it's open to participation from all the chair groups and research groups. As you may know, Wageningen is a combination of a university and a collection of public-private financed research institutes. And this program is coordinated by Dick de Ridder, who is a professor in bioinformatics, by Jene van der Heijden, who is the research coordinator at the Wageningen Data Competence Center, and me. And I'll give an overview of how the program is organized, some of the background, and some of the challenges that we are working on. You're welcome to interrupt if anything is not clear. This has already been very nicely covered by Luc, so I can be very brief about this. I have indeed a background in PhD in physics and astronomy from the Free University in Amsterdam. I have been working at the Highways Agency, the Dutch Highways Agency, so-called Rijkswaterstaat, in traffic and control. And actually, I will use this background to somehow introduce the work on digital twins that we are doing now in Wageningen. And indeed, I've been working at the Dutch National Office of Statistics and at the drinking water company. This all happened before 2017, when I joined Wageningen University and Research. And this is relevant because when I joined Wageningen Research, it was at the moment that the Wageningen Data Competence Center was started. And the Wageningen Data Competence Center is part of the efforts of Wageningen to develop expertise and opportunities in, let's call it, digitization of science. So also this investment program of digital twins is part of the investments from the university to bring the opportunities, any expertise of data science, of artificial intelligence, including digital twins, to the domain that Wageningen is researching. The Wageningen Data Competence Center is shown in the middle. It's a very small team. 8 people are more or less directly connected to it. And our job is to connect to the institutes of Wageningen, to the chair groups, to the investment programs, like I will be talking about this evening. Also to the staff departments for education, for strategy, and for value creation, and to the staff departments in library, information technology, and information management, because we believe that to develop our research and education competences, we need the support of strategy, we need the support of information technology. And rather than building one big group in data science and AI, we believe that we should build on the possibilities and competences that we have in all these different departments, and that it may well work to have a small team connecting the expertise from all over the organization, including external parties like we have on the campus, several companies and other companies, and also in global partnerships. So partly we coordinate investment teams like the one I will be talking about. Partly we are a kind of front door to people looking for expertise, and partly we organize courses and do representation for the university. So the Wageningen Data Competence Center started in 2017. And in 2019, we were asked to organize the investment team. In 2019, the theme Digital Twins started. It had an interesting growth, in the sense that we were wondering where we should focus as Wageningen. You can focus anywhere when you define a new investment theme. And eventually we found out that the concept of digital twins may be very helpful, because in developing a digital twin, you need to combine expertise from different departments. We are not developing a digital twin of a cow, but this image is a kind of visualization of what we have in mind. Once you would want to develop a digital twin of a cow, you need technical expertise of online data, of computer modeling, of data infrastructures, and you need expertise of what actually are the challenges in modeling a cow. What are the research questions that you may wish to answer? Who are the stakeholders who would be interested in such a digital twin? And what is the societal environment that you need to be aware of, for instance, regarding ethical aspects once you are developing a digital twin? And what would it mean to the farmers if such a thing as a digital twin may be developed? So we thought digital twins is a very nice subject to challenge ourselves in developing digital expertise in the university. But then the question, of course, came, what exactly do we mean when we talk about a digital twin? Well, this is a very simple sketch that we used for the discussion internally of what we would like to classify as a digital twin, and also to be able to exclude other things that we would not recognize as a digital twin. The digital twin in this picture is in the middle. It's the dark red circle. It is required to represent an individual system or process. It is required to be able to simulate this individual system or process, including potential perturbations in the system. It is somehow connected to the actual system or process, which is shown on the left in somewhat lighter shaded red, by a real-time sensoring or data connection in one way, in the sense that the digital twin receives information from this object or process and not necessarily gives direct feedback to the process. It can be, but it's not strictly required in our definition. Going to the other direction, it has basic user interaction so that somebody can work with the digital twin, ask questions, develop scenarios, and extract information from it, of course. All in all, it should provide actionable knowledge. It should help people prepare their decisions based on this system. And the feedback loop to the system is not through the digital twin, but it's through the persons interacting with the digital twin. The real strict requirements are shown in a dark typed characters. In the more light typed, light blue letters, there are the optional qualities. Of course, it's not forbidden to have a connection from twin to the system. It would be nice to have a modular setup, a multi-scale modeling feature to be able to make future predictions, and more advanced visualization, of course, helps. But in order to have a strict separation, we adhered at least to the dark type characteristics. We have also organized a program organization, as you may imagine. The total budget is 1.5 million a year for a period of 4 years. So we need some organization to distribute the money, to follow the process, to monitor the research, and to find out what are the real opportunities and challenges that we want to have developed in the university and research institutes. So what we eventually did, we defined 3 flagship projects, and I will go into some more detail later in this presentation about these 3 flagship projects. They're shown here in red, blue, and green. I will defer the details to later. And we also organized 2 platforms. The flagships are, of course, specific in-depth research projects. The platforms are intended to deal with the more cross-cutting issues for digital twins. And we identified 2 kinds, one regarding inclusiveness and the other regarding methodology. Methodology is about how to connect to the system with a real-time data connection, what algorithms we use, how we would like to visualize, and for instance, what metadata schemes should be used. The inclusiveness is more about involvement of stakeholders, ethical questions, and for instance, this morning we had a discussion about if we really can see a digital twin as a representation of a system, or if we had better seen it as a control mechanism, because the one gives totally different ethical questions from the other. A representation is a kind of thing which doesn't seem so challenging, whereas the control system may have much influence on society and may give rise to totally different societal questions. And then there is a team of organizers. I mentioned them before, Dick, Jene, and me, with the program support officer, Nera. And there's a core team connecting to all the different science groups, giving us input on progress, ideas, opportunities, and external contexts, for instance. There is also an idea behind the different phases in our program. As I mentioned, we started in 2019, and then we provided budget to different groups to perform feasibility studies. So we had a large number of studies, if I remember correctly, almost 30, and they all ended in a proposal for a flagship. From these studies, we selected 3 as the flagships. They are being developed now from 2020 until next year. So next year, 2022, will be the last year of this investment programs. And the idea is then that they, so to speak, conquer the world, or more or less that they are open to external participation, and that we will see how they will land and how they will be employed. And that phase is of course already starting now, and we hope then to continue this development with external partners, external funding, and that this investment team has provided the basis to continue using digital twins in our domain. So that's the idea behind the multi-annual program that we have organized with the organization I just showed. I think so far the organizational part. Then to shed some more light on what we have in mind with digital twin, a prehistoric example from my personal history. When I was working at Rijkswaterstaat about 20 years ago, we were working with real-time traffic monitoring data, which is shown on the map on the left of this slide, around Eindhoven, for instance. Rijkswaterstaat has real-time monitoring data available of traffic flow and speed every minute along the entire highway network of the Netherlands. And Unfortunately, as is happening again, there is quite a lot of queuing on the Dutch highway network, and there are traffic control centers being organized to reduce the queuing by so-called dynamic traffic management. And the question is, of course, part of traffic management is going automatically, but under unusual circumstances, this may not work well. And what is an operator supposed to do in those circumstances? How can operators be helped in guarding traffic and preventing more queuing than necessary to happen, given the fact that you have this wonderful collection of minute-by-minute measurements, which are available 1 or 2 minutes after real time. So it's not strictly real time, but almost real time, so to speak. And then you see at the top right of this slide, the system we developed. It was called beslissingsondersteunend systeem. So we haven't heard yet of the digital twin concept, but actually it is amazingly similar, where we use the monitoring data through a system which is called Monica, which has nothing to do with any American president at all. There is an estimation system to correct for measurement errors, inconsistencies. The corrected measurements are fed to a kind of historical database, and they are used to predict the traffic flow. As you can imagine, when you have the initial situation, you need to have some information on the regular inflows on the on-ramps, and also to have some information on the regular outflows of the off-ramps. And for this particular purpose, we needed the historical data. Once you have a prediction of the traffic situation, for instance, 1 hour ahead, you present it to the operator, and you give him the opportunity to make different predictions under different circumstances with different traffic control measures. And once he has made a decision by implementing or not one type of traffic control measure, it's again influencing traffic, and the whole loop starts again. So this worked pretty well. So the concept of digital twin, although it wasn't named like this 20 years ago in highway traffic management, was quite feasible. And it's being developed currently further in traffic control centers. But the interesting thing, of course, is the simulation part. How can you know what happens with traffic? And the good fortune that we had is that there is a very simple relationship that can be used to model traffic like it's a kind of fluid flow, which is shown on the left of this slide. When you know the density of traffic, so the amount of vehicles per kilometer per lane, you can more or less directly infer the traffic flow and also the speed from that. And up to a certain density, the flow is increasing, but when there are too many vehicles on the road, the flow is decreasing again. And this is a very simple relationship of a pretty complex phenomenon, of course, because it depends on how fast people want to go and how much distance they want to keep from their predecessor. But averaged over kilometers and lanes, there is this average behavior. And as you see to the right, we could relatively accurately predict traffic intensity, which is the number of vehicles passing a certain point, and traffic speed. You see the dotted lines, which are the predictions, and the continuous curves, which are the actual measurements. So this worked pretty well, but the interesting thing is that this is already a kind of digital twin of a living phenomenon, because traffic is not like industry, it's the sum of all the behaviors of many individual drivers. But now we are doing in Wageningen, 20 years later, something entirely different, I'm tempted to say. Namely, we want to build a twin with the 3 flagship projects of plant growth in a greenhouse. We want to do the same for the nitrogen cycle on a farm and the human fat response. And when you look at the plant, there is no simple relationship, as I just showed you, for traffic. And the same applies to nitrogen on a farm, because it depends on the weather, it depends on the soil quality, it depends on the plant species that you have, it depends on the genetic characteristics of the plants, and it, of course, also depends on the operations of the farmer himself, because that's the part we can influence, so it needs to be taken into account somehow. And the same applies to the response of humans to what they eat, in particular to how much fat they eat. I will go into some more detail of these three examples, but not before mentioning that there are many other initiatives coming up in these fields. Like in the European context, there is the idea of Destination Earth, which wants to build global digital twins. In the Netherlands, there is still the idea of building a digital cow, for instance, regarding the digital cow, because with the digital cow, you could avoid experimentation on living animals. If you have a good representation of the cow, you could investigate what medication would help in particular circumstances without having to test this on real cows. So there are great benefits in digital twins for living organisms. And last but not least, also in the African context, there are many ideas of improving environment in an economic valuable way, like using proteins from waste streams. And they need to be valued. And then it's very helpful to be able to study this process both on a micro scale, what proteins can you extract from what stream, as on the macro scale, what economic processes would be feasible to make this cost effective in the end. So there are many nice ideas, but also quite a few challenges. And this comes down to what I've tried to show here. Digital twin is in principle a subject which is quite easily explained, which can be applied to relatively simple systems like water treatment once you restrict it to the physical part mainly. But as Wageningen, we want also to see if this concept is viable in our domain with very complex living systems. Now, for the three flagship projects, this is the first one. It's called Virtual Tomato Crop. So it's focusing on the growth of tomatoes in a greenhouse. And we have many detailed models of tomato growth, like 3D models. We can even show how the leaves grow. And we also have models characterizing the influence of nutrients, seeing the effects of climate, air quality, etc. And the idea is to use these models in an environment where we also detect the circumstances, and in an environment where we also perform image analysis to actually see how the leaves are growing, and to feed this as a kind of initial situation to all these models, do some data processing, build a kind of virtual greenhouse to actually see how these plants would be developing in the virtual environment, and then to implement control and decision support, including genotype selection. So apart from the loop that you see at the right of the figure, which is more or less real time, there is also an offline loop where we can see what kind of genotype would be best. So what kind of plant species should be chosen under the particular circumstances that we have, because there are different cycles involved in this process. One is the operational cycle of climate control, of nutrient control, and of light control. On the other hand, there's a more long-term cycle of once the plants need to be replaced, what types to select, and what new developments there are from growers, breeders, consultants, and suppliers. Well, as you may well be aware, this is a quite capital-intensive sector in the Netherlands, so there is quite some interest in increasing the margins and decreasing the losses and improving the quality of the vegetables that we grow. There are various activities being undertaken here. There has been a stakeholder analysis, exactly what do people expect from a twin. We checked whether we can accurately test the phenotype, which is how the plant shows. And there has been a lot of work on selecting the models that can be integrated, because you may have models for the different parts of this process, but then also they need to be integrated into a whole, which is the real challenge often. And in 2021, so this year, we continue with the experiments. There has been advanced model fitting using deep learning, and we are taking steps in the integration. By the way, On the right, on the lower right of this slide, you see the National Plant Eco-Phenotyping Center included, which is part of the NWO research infrastructure, which has been specifically developed to characterize plants at different scales, from the micro scale to the macro scale, so from inside microorganism and even molecular scales up to the external scales where we have also fields being monitored. And this very nicely fits the ambition of this twin, because for the twin we also need to characterize the plants. So there are cross connections of this investment program with other developments at the university. That's the first challenging flagship. Now we come to the second, maybe even more challenging. And I say maybe even more because in the greenhouse environment, we are used to advanced systems like climate control. Greenhouse is not a factory, but there's a lot of electronics already involved in feeding plants and in keeping the climate inside between bounds. Whereas in this particular twin, we focus on humans. And the ambition here is to provide individual and interactive dietary advice to people who may or may not experience the consequences of eating lower or higher fat levels than they should, given their particular health situation. Now, there are, of course, so-called dietists being able to advise you what to eat and when to eat, but usually you don't have somebody like that available all the time. And many people do not want to go there at all. Globally, it's quite a challenge for people to deal with that. And there are many adverse health consequences for people not knowing how their fat response is. So with this twin, we mean to provide very easily accessible advice, taking into account your particular genetic characteristics, your physical health, the amount of exercise you take, and also the diet that you usually have. But it's challenging because other than the greenhouse, there is no real control system operational on you. So somehow we need to find ways to collect data from people, and somehow we need to find ways to provide advice and to collect the feedback. So providing the advice through a mobile telephone is not the most challenging thing, of course, but to get the data from the people is a real challenge. So far, we have only been able to partly collect offline data, and there are many ideas for collecting online data with, for instance, sensors in the blood or under the skin, but those are not operational yet. Still, with this development, we believe that we are one of the first really trying to make this happen. And what you can see here is in the different years, we also have spent time collecting data, investigating how people would respond to this advice, because we could have this wonderful idea of presenting them with an advice, but do they follow it up at all? To see if they accept it, and also to see what people are interested in using this. And especially in this twin, but also the other twin, there is a lot of interest in trying to do this because, well, you are, some of you at least are in Eindhoven. Health is quite an important issue, as also our national electronics firm has realized. And we continue this work in trying to realize this twin. So that was the second. The third, which I already mentioned, is the digital future farm. And here the ambition is to build a digital representation of an entire farm, particularly focused on the nitrogen cycle. And why the nitrogen cycle? That is because it's quite an issue in the Netherlands how we deal with our nitrogen. And this is for a large part also influenced by the operations of a farmer. What kind of crops does he grow? What kind of nutrients does he give? How is his water management? How does he feed his cattle, etc.? And rather than finding out each time again what to do, it would be helpful to have a digital twin environment directly connected to a particular farm to see ahead what policies would be workable. we first aim now to help farmers with this environment and also researchers, but already also the ministry, the policymakers are also quite interested, of course, in how they could use this type of instrument. As you can see, in 2020, we started with the basic infrastructure setup. And here again, there is quite some detection and sensoring happening already on a farm, but we are afraid that we need to know much more than is being measured so far. So we also need to rely on manual reporting. This is one of the challenges. We need to know the operations of a farmer, for instance, and for that a farmer needs to register it somehow. So that is one of the very practical challenges that we have. But then also modeling is quite a challenge, because also here, like in the other two twins, we don't have this very nice, simple relationship that we had in the year 2000 when modeling traffic. So what you see here is a representation of a so-called crop growth model, where you simulate from input data the output data, and that is actually how much grass has been grown, which is the thin blue line on the bottom at the left part of this figure. And what you see above is the required data, for instance, of how you call it, temperature, nutrients added, or also water regime added. And what you see is that you need pretty accurate information to be able to provide a good simulation, whereas in practice, and now we turn to the left part, we need a kind of simplified but still accurate model, because the accurate simulation on the left would just be too much in computational requirements to have an effective twin. So we definitely need to simplify. We need some kind of AI model to have a sufficiently accurate representation. So in this case, we tried a random forest model and found out that with far less data, we could actually find a good representation over multiple locations. And we did so for the case of New Zealand, where you can see different locations on the map to the left. And what you see on the right are the more or less the residuals, so the error bars. And the requirement was to have the errors less than 5 kilogram nitrogen deviation. And it appeared possible to do so with a random forest trained for different locations, where we averaged everything. So we didn't even need to take into account the individual circumstances, which is quite important, because it would also mean that we would require far less input data to provide accurate simulations over an area of, well, the size of New Zealand. So this is for us pretty important, because once we would turn to applications of this digital twin over different farms in the Netherlands, it may be feasible to simplify very much the models that we need if we find a good representation and we use the right input parameters. So this is just an illustration, not only about the application side, but also about the scientific potential. In this manner, we think it may be helpful for our domain to think about what kind of data we need, for instance, from remote sensing, from in situ sensing, from surveys, from farm management systems, and also from breeding trials, how we could develop a smart environment in selecting the data that we have, and then develop some kind of data-driven hybrid AI to be used in digital twins without the need to simulate everything in detail, which would be completely impossible in a complex system, even as small as a single farm. Because then you would need information on the landscape, the soil, the climate, well, all the parameters that you see on the left of this picture. And this is just not feasible to build a twin. So we definitely need to simplify. What I have shown you before is an example of this growth of grass in New Zealand. But scientifically, there will be many more questions that need to be answered to see if this approach would really work. Now, I'm almost on the way to concluding. There are some remaining questions that are challenging us. Because we do all this effort of developing digital twins, but of course we need to compare them to some kind of baseline. The idea is we may be able to develop a digital twin, but what exactly do we need for that, and what exactly are the potential benefits of these twins, because they're not for free. So for instance, starting with the digital future farm, we think the main difference with what we currently can do is the use of real-time data. And with that, I mean that, of course, there are already crop growth models that can be used, but usually we don't have the real-time connection to the weather, to the soil quality, and to the plant growth to feed. In case we have this real-time data connection, we believe we can provide far more accurate simulation results because the initial conditions are much better known. And we can even improve on these simulation results because we can better estimate the model parameters by developing a kind of feedback loop with the real-time data. And we could even develop more accurate models, not just by tuning parameters, but by improving our models, for instance, using a kind of AI type system like I mentioned to you before. So we believe that there are potential benefits that we intend also to find out if this really materializes in the research that we are doing and will be doing next year. For the next case, which is the greenhouse tomato crop twin, we know that there are already automatic climate control systems. So what would be the benefit of a digital twin? Now, we believe that it would be very beneficial to provide the opportunity of interactive scenario explorations, which is not offered by climate control systems. They are far more limited than the possibilities of twin. And this would enable crop growers to recognize and prevent undesired scenarios and also to develop and select preferable scenarios. So here, the focus is a bit different from the previous one, whereas the previous one focuses on a real-time data connection. Here, the real-time connection is more or less available, and we think we should focus on a very well-developed user interface to enable this interactive exploration of scenarios for the crop growers. And now for the last one, we believe that there are at least two differences in the twin for human digestion. One being that you can provide user interactive advice in the sense that the user can ask questions, and it can also be individualized to the user. But one is still missing here, and that is that it is far more easily accessible than would be when you would have to go to some consultant or dietist to help you with this advice, because you can already receive user interactive advice by going to a specialist, or you can also receive individualized advice by going to a specialist. But this can be done every few weeks at most, whereas people sometimes need daily advice depending on their health circumstances. So here the real benefit would be not just the two I listed here, but as I learned this morning, it's even more beneficial to have this readily available to users. So this also poses high demands on the use of the data from the people. So we definitely need some way to be informed of what they eat and of their physical response. And then there would be a real benefit in this twin. Evidently, there is also a lot of societal potential for this type of twins. This is an investment proposal from the Dutch Geoinformatieberaad. As you will be quite aware, there are many transitions happening also in the Netherlands regarding housing, regarding energy, regarding climate, regarding agriculture, and regarding infrastructure. And there are many hard choices to be made here. And it would be very helpful to have at some not too detailed level twins available to see how these choices would develop and also to monitor what's happening. And there are several initiatives now, for instance, from GeoNovum, to prepare this type of work with a kind of data infrastructure so that researchers can build their twins using this kind of data infrastructure. So all in all, we believe it's quite an interesting direction. We hope to contribute with this investment theme, and we still have many research challenges to answer. And this is more or less what I had to say. I will stop sharing and give you the opportunity to see each other again.